just got off the panel with some self-driving car people from Cruise, from Rivian, from um, from Didi, and then a chip company, Brain Chip, which does neuromorphic compute. So the takeaway from the panel, I think the big question that is also morphing into the big question for the Tesla AI Day is going to be, what are you guys doing in planning and control? Basically, you're using AI for computer vision, but you're not using AI or very little AI for actual planning and control. And how is this space going to evolve? I asked the question of DeepMind approach, mu zero, and one of the participants, the Cruise guy, said that this is a dream. So clearly, this is the right path, and that's a good thing. That's good to be on that side of things. The question is, why isn't it being used? And well, that's the big question that I have for Tesla. This is not even on podcast. It's September 15, 2022. This is Krim Delco. For the day, the fund is up 85 basis points. The market's down 1.15%. For the year, we are down 23.8%. The market is down 18.5%. We're underperforming by 5.3%. Just before I go into the topic, we had a very good outperformance in the last couple of weeks, actually. And as I just said, we're underperforming by 5.3%. So we're almost closing the gap. We're still down more than 20%, but at least we're closing the gap to the market, which is a very good sign, relative strength, coming from both sides, Tesla and our biotech side of things. So now let's talk about this. So this is the most important panel of the hardware AI summit that I attended in the last 3 days. So I want to finish this. It's probably my last episode about the summit. Nevertheless, what's important here is really the question of planning and control. Let's just jump right into it. So planning and control, I think even the Tesla AI Day last time when they presented showed that this is becoming the bottleneck in terms of reaching level 5. And I spoke with one of the guys in this panel, which he works for Cruise now, he was with Google, and he said, this is the Northstar, this is where we want to go. We want to get to the point where we can use the driver, we can treat the driving problem like a game problem. It's like a game, and we have, instead of supervised learning problem. This is the key, because we have too many degrees of freedom. It's too complex, and we can't just supervise ourselves through this. So this is, I think, the conclusion, and the big question I have for Elon Musk and the whole Tesla team is, how are you doing this? Now, I asked another person from Cruise, actually, the head of, I don't know exactly what their positions are, but they're working in the hardware, software, AI space at Cruise. And the question, he said that we're doing very little AI in terms of planning and control. So planning and control is pretty explicitly programmed. So once you see this, do that. Once you see that, do this. And I think Tesla is using a supervised learning approach or behavioral cloning approach, which is fine, and it's helping the company and us customers to get to a pretty high level of self-driving. But to get to that next level, the mu zero approach, basically, where you have superhuman driving and superhuman performance and superhuman safety, and this is the key. To get to that level, we need more than that, and I think the the mu zero approach is probably going to be the one. Now, for that, we need animation. So I guess this leads me, I've spoken about this before, and the situation is the following. So we have a problem, which is we have robots going in the wild, and the robots need to learn how to behave themselves. And for that, we have a certain hardware stack and a certain software stack that needs to be evolved in order to achieve that goal. And I think this conference has given me enough confidence to answer two questions. Let's start with the software stack. I think the software stack, the perception side is extremely good, and it's even getting better. And on the control and planning side, we're in the early steps, and we have to find a way to morph from supervised learning towards a more gaming approach, meaning self-supervised reinforcement learning. We have to find a way, and the road can only go through some sort of animation. So we need animation to get to the level where we can then have self-supervised reinforcement learning being applied to the car problem. So this is I think this is my conclusion. It's being reinforced at this conference. There's not too much discussion about this. I was the only one who brought these things up. So this is fairly new, and I'm curious how Tesla will react to that. Now, having said that, let me finish. And then another thing that needs to happen is on the hardware side, we need to have a more seamless transition from the edge to the cloud. So we need to find ways to communicate, on the one hand, the training side of things and then the inference side of things more seamlessly. So right now it's a little bit more extreme where we collect the data, load it up to the cloud, train, and then bring it down to the computer and then use inference. This is what Tesla is doing. This is what pretty much everybody else is doing. It's working, but I guess we need to have a more seamless approach because we want to be able to learn and do inference at the same time. This is the key. Why? Because we want to be more adaptive. And I think I want to close this episode with something that the DeepMind guy said when I met him. And if you look at what problems DeepMind's working on, I think those are the kinds of problems that are really interesting. And it's pretty much every problem can be reduced to a game problem or a game theoretic problem. This is why game theory is so crucial in economics, but it's not just for economics, it's for pretty much anything. So driving is a game where I do certain things and I expect others in nature to do things and then I react. And in order to get to the level of being able to adapt in real time to all the inputs and play that game, in other words, drive safely and get to a certain destination, I need to have I need to be more flexible in the way I learn, and I need to be more flexible in the way I do inference. And I think for that, we've spoken about this already in the previous episodes. Neuromorphic compute is one of the things that can be done here, which is find ways to use a lot less power when you run the models, and maybe you can do it then on the premise, on the device, and then also on the big scale. So when you do the supercomputing learning on the data center, over there you have to do something similar because you can then use the massive models. We're talking about the billions, maybe at some point trillions of parameters. And in that case, if you do, like the GraphCore guy said, if you do, I don't know how many billion parameters per clock cycle, you're gonna get into power problems. It's just a lot of back and forth there. And therefore, you need to find ways to route input data to the right node. So those are the big takeaways here that I think are relevant not just for the self-driving car industry, but for everything that's related to AI. But we're focused on AI at Orange Capital Partners. So to summarize, my discussion with the autonomous driving panel was very fruitful in one particular way, which is they did acknowledge that the AlphaGo Zero approach is feasible and it's a dream and it's a Northstar. Now, it's not achievable right now because we don't have the animation that is necessary. And actually, quite frankly, we don't have the algorithms and the compute, at least to my knowledge. And it's going to be part of the work in the next couple of months on our side to find people and interesting places where that kind of work is happening. Because we believe that this is important. This is not just some idea or some creative twist to a situation. This is where this needs to go. And of course, there could be new innovations coming. We don't know what kind of innovations are on the back burner. One of them, of course, the transformer side of things. But we believe the transformer side of things could be very helpful for the animation side. We're not so sure about the self-supervised reinforcement learning side. But if we have better animation, if we have AI-driven animation that is rooted in reality, so we have, like my proverbial road in Alaska, that I can iterate billions and billions of times with all kinds of possible sort of Monte Carlo search tree type scenarios. So basically, if I could have a similar approach like AlphaFold has when they use the Monte Carlo search tree for the next possible move, something along those lines for the car, I think would be absolutely crucial and would bring us to these levels, whatever it is, level 4, level 5. Disappointingly, DeepMind is not working on it. I believe they're not working on it because Google doesn't want them to work on it. And that question is, why is that? Either Google has a secret project they're not talking about, or they're just stupid. I don't have another answer. But anyway, I think this is the big question for Tesla. Again, just to be very concise now, is self-supervised reinforcement learning the path forward in planning and control? Do we have the necessary animation tools to do that? Thank you.